Imagine waking up one day to find that the reality you've always known, a world of 3 dimensions and a steady march of time, is just the tip of the iceberg. What if everything you see, every decision you make, and every moment you experience are fragments of a much grander, unseen structure? This is the world we're about to explore, a universe not confined to the familiar, but stretching into realms beyond imagination. At first glance, life seems straightforward. We exist in a space where we can move left and right, up and down, forward and backward. Time, though intangible, pushes us ever forward. But as science has revealed, the universe plays by rules that defy common sense. Beneath the surface of our everyday experiences lies a hidden reality, where dimensions fold upon themselves, particles act like waves, and time may not flow the way we think. Let's start small, single point. It has no width, height, or depth. It simply exists. Now connect 2 points, and you have a line, the first dimension. Add a second direction, and you create a plane, like a sheet of paper. Fold that plane, and you step into the third dimension, the space we call home. But what happens when we continue this pattern? What lies beyond the third dimension, beyond even the fourth dimension of time? This is where the story becomes truly fascinating. Physics tells us that there may be as many as 10 dimensions or more, each one unlocking new layers of possibility. These dimensions aren't just theoretical ideas, they could hold the key to some of the universe's biggest mysteries. Why does gravity behave the way it does? What gives particles their mass? Why is the universe expanding? The answers may be hidden in these unseen dimensions, curled up so tightly that they escape our perception. And then there's quantum physics, the branch of science that feels more like magic. Imagine particles that can exist in multiple places at once, or that change their state simply because you observe them. Quantum physics challenges everything we think we know about reality. It forces us to confront the idea that the act of looking at the universe might shape it, and that multiple versions of reality could exist simultaneously. When these two worlds, quantum physics and higher dimensions, come together, the picture grows even more astonishing. Dimensions beyond the fourth might explain the strange behavior of particles, the existence of parallel universes, and even the flow of time itself. They may offer pathways to other timelines, alternate realities, or completely different versions of existence. But how do we make sense of something so abstract, so alien to our everyday lives? We'll start by peeling back the layers, one step at a time, building from what we know and gradually venturing into the unknown. Along the way, we'll encounter ideas that seem to belong in the realm of science fiction like time travel, the multiverse, and the fabric of reality itself. Yet, these are grounded in cutting-edge science, pushing the boundaries of what's possible. At its core, this journey isn't just about science, it's about perspective. It's about understanding how small we are in the grand scheme of things, yet how connected we are to a universe far larger and more intricate than we can fathom. By the end of this exploration, you may never look at the world the same way again. So take a deep breath. Set aside your assumptions about how the universe works. This is the story of quantum physics and dimensions. It's a story of infinite possibilities waiting to be explored. Quantum physics and dimensions are mind-bending topics that challenge how we perceive reality. Most of us are familiar with the first 4 dimensions. After all, we live in a 3-dimensional world, and time serves as the 4th dimension, guiding us through our existence. But what lies beyond? The exploration of dimensions takes us on a fascinating theoretical journey, one where our sense of space and time is stretched beyond comprehension. Today, we'll build a mental construct of dimensions, progressing step by step until we reach the concept of the 10th dimension, construct so vast it encompasses everything we could imagine and more. We begin at the very foundation of dimensional theory. The first dimension isn't something we intuitively grasp in everyday life, as it's simply represented by a line. A single straight line connects 2 points. These points have no size, no dimension. They are purely descriptors, indicating specific values or locations in a system. Using this line, we establish the first dimension. But as simple and abstract as this may seem, the first dimension lays the groundwork for all others to come. The second dimension adds width, offering an expansion from our one-dimensional line. Imagine drawing another line branching out from the first. The result forms a shape akin to the letter Y, representing length and width. This step up gives us flat, two-dimensional objects and opens the door to concepts like geometry and shapes we see in everyday life, squares, circles, and triangles. But while we live in a 3D world, contemplating dimensions below ours can feel oddly reductive. How can something exist without depth? Yet, within this realm of theory, everything begins as a conceptual framework, progressing one dimension at a time. Entering the third dimension, we encounter the space we occupy every day. A world of length, width, and height where solid objects exist. To understand how dimensions progress, physicist Edwin Abbott provided an illustration in his book, Flatland. Consider the Flatlanders in their two-dimensional existence. To them, the third dimension is entirely alien. Imagine being able to interact with Flatlanders. You might appear to them as a series of confusing cross-sections, cutting through their 2D world in ways they cannot comprehend. Similarly, folding their two-dimensional plane enables interactions their perspective would never allow, like an ant crossing a folded newspaper. To us, the fold is effortless, but to the Flatlanders, it's magic. Now, we ascend to the fourth dimension, a concept many associate with time. Time, parallel to our spatial dimensions, moves in one direction, connecting moments like points along a line. If you were to imagine yourself as a fourth-dimensional being, you might visualize a snake-like form weaving through space-time, with your birth at one end, your death at the other, and your current self existing somewhere in between. Consider the intriguing notion that time itself unfolds as a spatial construct, much like a highway connecting one universe to the next. This interpretation of time unveils the idea that every moment of existence is interconnected, tethered by the flow of the fourth dimension. The fifth dimension ventures into alternate realities, possibilities branching like a Mobius strip, twisting and looping in ways we cannot directly perceive. Although time appears to us as linear, within the fifth dimension, multiple timelines coexist. Choices, chance, and external factors influence the splitting realities. For instance, one timeline may represent your life as it is now, while others might reflect alternate versions, paths not taken, but still theoretically possible. This expansion into possible realities offers a mind-boggling perspective, branching endlessly beyond our immediate perception. Progressing into the sixth dimension deepens the complexity, as we now consider all possible states of existence within a single timeline framework. Imagine being able to view and compare all alternate realities side by side. The completeness of outcomes, both unfolding and unfulfilled, melds into a cohesive picture provided by the sixth dimension. If we strain our imagination, the visual complexity overwhelms us, as every choice, every influence, and every ripple throughout a timeline converges here. The seventh dimension transcends into intricacies involving entirely separate universes. While the fifth and sixth dimensions explored alternate realities within a familiar construct, the seventh takes us beyond our universe. Each universe would have entirely different laws of physics, unimaginable structures, and frameworks unlike anything within our existence. Though difficult to fathom, this realm theorizes that what exists beyond our perceived cosmos could function under an entirely separate set of principles, a concept physicists attribute to string theory and the multiverse hypothesis. The eighth dimension builds upon this further, comparing multiple universes under different sets of universal laws. Each possibility, including branches of physical fundamentals and constants, occupies its place here. Imagine comparing cosmologies as though flipping through pages in a multiversal guidebook. Understanding the eighth dimension requires detaching ourselves from assumptions about absolute truths in physics, recognizing that what governs our universe may be only one of infinite models. The ninth dimension moves even closer to the incomprehensible. While earlier dimensions confined us to structures of reality that reflected physical or conceptual expansions, the ninth gathers all possible physical laws and cosmological frameworks into one meta-dimensional construct. This dimension combines every conceivable rule of existence within all universes, suggesting a total cosmic framework encompassing all facets of reality. At the peak lies the 10th dimension, metaphysical boundary where everything is contained. This final dimension unites all existence, every law of physics, universe, reality, and timeline. It represents an everythingness, unable to be oversimplified or even visualized. Our minds struggle to grasp its enormity because it exceeds even our most vivid imaginations. Yet, mathematically and theoretically, the 10th dimension completes the framework of multi-dimensional theory and provokes awe in its sheer expansiveness. This dimension transcends boundaries, encapsulating all possibilities within an unfathomable structure of totality. Now imagine, for a moment, that the very fabric of our reality isn't as concrete as it seems. What if everything you see, touch, or experience is shaped by an act of observation? According to quantum physics, things get pretty strange when we zoom in to the subatomic level. Particles, tiny building blocks of our universe, aren't actually solid entities. Instead, they exist as waves of probabilities, fluctuating between countless possible states. Here's the perplexing part. It's our observation and our attention that pulls the particle out of this wave like uncertainty and collapses it into a single state. This phenomenon gets us asking some pretty mind-bending questions. If particles don't settle into a specific state until we observe them, are we, in some way, creating reality by simply experiencing it? And if so, how far does this idea stretch? This is where things start to unravel in two seemingly opposing directions. Some physicists argue that quantum effects, while fascinating, are limited to the subatomic world. These phenomena, they believe, don't apply to the physical everyday reality we experience. But others see a deeper connection. After all, subatomic particles make up atoms, and atoms form the molecules comprising everything around us, even us. If particles only collapse into reality when observed, does that mean we, as observers, shape the physical universe? This line of thought raises even more questions. For example, if observation is what turns possibilities into tangible reality, what existed before any observers? Before humans or even animals, who or what played the role of the observer? Did the universe exist as endless waves of probability, never settling into form? Or was there always something or someone cosmic observer untangling the quantum soup and setting it all into motion. The thought experiment doesn't stop there. Take the many worlds theory, which suggests that every possible quantum outcome simultaneously exists in separate, parallel universes. That means for every decision, every observation, there are realities branching infinitely in directions we can't perceive. But then, why don't we see these alternate realities? Why does one world appear so solid to us? The answer lies in something physicists call decoherence. It's a bit like looking at a slightly blurry photo. Up close, you can detect the small inconsistencies and fuzziness. But as you step farther away, the image sharpens into something distinct. Similarly, as we zoom out from the subatomic scale to our everyday world, the remaining quantum possibilities fade into the background, leaving us with one coherent version of reality. The other potential realities, they're still out there, but they've effectively disappeared from our perception. This creates a fascinating interplay between our act of observing and the universe itself. Each observation is like cutting ties with all the other possibilities, isolating and solidifying the state of the world around us. But this isn't the end of the mystery, it goes even deeper. Some physicists using the many worlds approach argue that we don't actually collapse anything. Instead, our observation locks us into one slice of a multi-dimensional quantum tapestry, where all other potential states continue to exist in parallel worlds. Think of it as tuning into one station on a radio. All the other stations still exist, but you're only hearing the one you've selected. Now, stepping back, consider the enormity of this idea. If the billions of individual choices made by observers, whether humans, animals, or something grander, are constantly pulling realities out of quantum uncertainty, what does that mean for causality, the flow of time, and even history itself? Could it be that every single moment exists not as a fixed event, but as a possibility waiting for observation to make it real? Here's another brain bender. If observers are necessary to create reality, when did the first observer appear? One idea is to place the observer at the origin of everything, the Big Bang. But what if observation isn't bound to time as we perceive it? What if the arrow of time is simply an illusion, a story we construct in what physicists call the fourth dimension? Could the act of observation ripple backwards, creating billions of years of observable history stretching out from a single point of awareness? Picture this. You're entering what physicists speculate as the 10th dimension, a realm containing all possible states of existence, every timeline, every version of reality, all at once. From this ultimate vantage point, the act of observing a single outcome could render an entire history, complete with billions of years of evolution, leading straight to the present moment. Strange, isn't it? What if this process rewrites not just your present, but fabricates an entire coherent history leading back to your starting point? But if this all sounds too abstract, here's a grounding thought for comparison. Many have pointed out that interchangeable terms like observer could just as easily be swapped out for words like creator or even God. If you believe in a divine force creating reality, the role of observer might closely align with such ideas. But this isn't about imposing one view over another. Instead, it offers the intriguing possibility that each of us, by observing the world, is participating in an act of creation, time. We experience it as an unstoppably linear flow, an arrow pointing us in one direction, from the past to the present and into the future. It feels fundamental, unshakable, and yet, beneath our everyday understanding of time lies a puzzling truth. Physics tells us that this unbroken march forward, this arrow of time, might be more fragile than we think. Arthur Eddington, a renowned astrophysicist in 1928, coined this evocative phrase, the arrow of time. It's a fitting analogy because our experience of time seemingly mirrors that of an arrow in flight. It propels forward, always toward a target, with no way to trace its path backward. But here's the mind-bending twist: many physical laws, like those found in Einstein's theory of relativity, have a strange property called time reversal symmetry. This means that these laws of physics work just as well if time runs backward as they do forward. Yes, the equations governing our universe don't seem to care about the direction of time. But wait, if that's true for physics, why does our experience of time feel so directional? Why can't we unspill spilled milk or unburn a candle? Could it be the way our brains are wired? Or is there something even deeper embedded within the universe itself that dictates this flow we perceive as time? To answer that, we first need to understand chemical processes. Think about a basic chemical reaction where two components, A and B, combine to create C. This reaction is familiar to us because it aligns with our understanding of time's forward direction. But here's the wild thought. Physics would say it is just as logical for this reaction to reverse, that is, for C to break apart into A and B, as long as nothing external disrupts it. However, in our observed reality, we don't often encounter this reverse reaction. Why? What locks time into moving forward? Some fascinating scientists suggest the answer lies within the very origins of life itself, within the primordial soup. Imagine, if you will, a chaotic, bubbling concoction of molecules billions of years ago. Particles colliding in ways that might spark the earliest forms of life. Now, here's where things get weird. What if, purely by chance, the processes that align to create life just happen to flow in what we call the forward direction of time? Could it have gone differently? Could there have been a version of life that evolved in the opposite flow, organizing itself in what we'd call reverse time? Consider the implications. That if such a reverse time life form existed, its processes, its choices, its very existence would appear alien to us. Cause and effect would unravel in unimaginable ways. Actions that seem random to us would probably make perfect sense to them, and vice versa. What if we tried to take this a step further? Picture this strange scenario. An alien race, whose timeline flows backward relative to ours, arrives on Earth in the year 3000. To them, this is the start of their invasion. Their empire grows while humanity fades away. By 2500, the aliens have entirely taken over, and by 2000, humans are completely wiped out from their perspective. The story ends there, except it doesn't. Because through our forward-flowing perception, the events are reversed. Humanity starts in 2000, encounters scattered alien threats, then gradually pushes back. By 2500, we've eliminated the alien presence for good. But who truly wins in this paradox? Neither. Both. Here's where it gets even trippier. Imagine these aliens aren't just science fiction, but tied to physics itself. One theory posits that how we experience time could be a quirk of quantum observation. The act of observing reality as complex organisms could pin us to the arrow flying in one direction. But does that mean another form of life, observing from a different perspective, could exist tethered to the opposite flow of time? What would it mean to meet such beings whose sense of cause and effect doesn't align with ours? Perhaps the easiest way to imagine this is by thinking of the universe's end. Scientists debate whether our universe will culminate in a big crunch, cosmic implosion, reversing the Big Bang door in a cold death, where entropy wins, leaving all lifeless and scattered. But what if, to an observer moving in reverse time, that cold death isn't an end but a beginning? What if reverse life forms see it as their version of the Big Banger, universe slowly gathering, organizing, sparking life and consciousness along its collapsing timeline? It's not entirely hypothetical. The mathematician and complexity theorist Stephen Strogatz explored how order can sometimes spontaneously emerge from chaos. If reverse processes like those in a cold death universe can somehow produce life along their time axis, it raises dizzying questions. Could they form civilizations just as rich and intelligent as ours, just backwards? Could they be collapsing toward us even now? And then there's this, a thought exercise of immense peculiarity. What would happen if both forward time and reverse time life forms existed simultaneously? Imagine trying to communicate. Our effect would be their cause, and their effect would be our cause. Any attempt to understand each other would devolve into chaos, our actions seeming random to the other. Would cooperation even be possible? Or would our mutual incomprehension doom us to conflict and destruction? Here's something even more tantalizing. What if they've already been here? Could the aliens whose timeline we just imagined be closer to us than we think, but we lack the ability to perceive them? Could they exist in a parallel universe, only occasionally brushing against ours? To grasp this, we need one more leap. Consider the laws of relativity. Einstein's equations imply that as we near the speed of light, time stretches and distorts. But what if this property doesn't only apply to speed? What if there are regions in space-time allowing beings to traverse backward rather than forward? Would their experience of light remain constant, as it does for us? Could we ever invent technology advanced enough to glimpse their world? Here we find a potential thread connecting everything, the speed of light. No matter how fast we move, light outpaces us. It's constant. If time's arrow feels more real to us because of how we collapse quantum probabilities, events turning into things, we might imagine reverse time beings doing the same, but for them, probabilities collapse in the other direction. Light, for these beings, zips away just as it does for us, solidifying the notion that once we confront time's symmetry, some constants like light bind us all. But what if there's a way to break through this barrier? What if we're close to uncovering a deeper truth about time itself, one that dissolves the divide between forward and reverse? Could there be a perspective beyond time entirely, where these distinctions simply cease to matter? And more intriguingly, if we could step outside time's flow, what wonders might await us there? Now picture a reality where every decision, every outcome, and every timeline unfolds simultaneously interwoven within the vast, multi-dimensional fabric of existence. Imagine a place where the boundaries of our three-dimensional understanding dissolve, revealing an intricate system where time is not a linear arrow, but rather a navigable dimension. Within this conceptual framework, the binary viewpoint AC perspective often associated with categorization and the simplicity of yes and no becomes the key to unlocking the mysteries of existence itself. The binary viewpoint can be likened to a map made entirely of choices, cascading system of yes/no decisions that has shaped everything we experience. From the initial flicker of the Big Bang to the grand elegance of the cosmos, our reality is an intricate pattern of binary decisions. But this framework is not merely a way to understand the universe, it is a way to reconstruct the very mechanics of reality from its inception. Some suggest this analytical binary perspective reflects a specific way of organizing information. But from this lens, it allows us to peer into the very structure of multidimensional existence. Now, consider the Big Bang, that astonishing moment where everything we know and are began. Current cosmological theories describe this as an extraordinary explosion, a fraction of a second in which the universe inflated by a factor so enormous it defies human comprehension. This inflationary cosmology is held as truth by modern science, but could there be another way to interpret this data? Could the Big Bang itself be seen as the first yice, the initial binary toggle in an infinite system of decision points. What if the observable effects of the Big Bang, the expansion, the energy, the creation of matter, were simply the reverberations of a single binary moment rippling through the fabric of the highest dimensions? What we describe as a rapid inflation could be akin to flipping a switch, unleashing all possibilities within that first binary response, yes or no, creation or not. And yet, this binary perspective does not simplify the universe, it adds layers of elegance and complexity. Looking further back, to the so-called moment before the Big Bang, we encounter mysteries that bend the intellect. What existed before? What kind of fabrica, potentiality without form, could give rise to existence as we know it? From this lens, the dimensions above our own could contain every possible reality, each woven into a hierarchical tapestry of choices. Where we see beginnings and endings, perhaps the larger system sees intersections, places where all possibilities converge and diverge. To trace our universe back to its inception would be to imagine peering not at the birth of time, but at the central branching point in a tree that extends infinitely in all directions. And this interplay, this duality of yes and no is one that science mirrors throughout its history. When Newton described the laws of motion and gravity, he built a framework so precise it remains a foundation of physics. But when Einstein came along, redefining gravity as the curvature of space-time, did Newton's laws become obsolete? Hardly. Instead, Einstein's vision expanded Newton's foundation, offering another layer of insight into the same data. Neither is fully wrong nor right, but together, they present two interpretations of a single cosmic rhythm. Could this not be seen as analogous to the binary framework? Just as Einstein did not dismiss Newton, but rather enhanced the field with a deeper understanding, binary decisions give rise to multitudes, expanding how we view the cosmos. This multiplicity extends to other modern theories. String theory, for example, posits that the fundamental particles making up the universe are not solitary points, but vibrating strings of energy. And M-theory, the evolution of string theory, suggests that this framework unifies 5 seemingly competing theories into one elegant structure. Within this lens, the supposedly chaotic foundation of our universe becomes an exquisite harmony of interlocking strings. But even here, M-theory does not negate the truths discovered by its predecessors. Instead, it offers yet another way to view the binary choices encoded in the cosmos, lens through which we see not chaos, but the mathematical elegance tying existence together. And here lies the crux of the binary viewpoint, not as a limitation, but as a tool for imagining possibilities. If every choice leads to an alternate reality, every yes birthing a branch of possibilities, where do we find ourselves now? Imagine walking through time, not as a path, but as a forest, where every step creates new branches, new timelines, and new opportunities for existence to recalibrate. Imagine that everything we consider unique, single moment, a single universe, is simply one path among infinite others. Even time itself, when viewed through this lens, becomes malleable, bending to the observer's perception. Though we experience time as a one-directional flow, from the past to the present to the future, some physicists and thinkers describe it instead as a dimension much like height or width, one that could be navigated forward or backward under the right conditions. If we abandon the convention of time as linear, we can imagine a reality where its direction could reverse, creating a universe that flows back into order from the cold chaos of entropy. Could such a reverse universe exist alongside ours, coalescing in the shadow of our reality? Theoretical physicist Richard Feynman brought forth a striking concept, with his sum over paths method, a way of understanding quantum systems by accounting for every possible path a particle could take. Applied to the cosmos, this concept suggests that our universe, so ordered, so intricate may be simply one among countless paths chosen by the rules of probability. Here, once again, the binary paradigm emerges, guiding us to an interpretation where the most statistically likely path stands out from the infinite possibilities. But if all these paths exist, overlapping within higher dimensions, could our universe be an unlikely accident? Or could it be simply one of the more probable choices within a vast multidimensional probability space? Such questions are what the binary viewpoint invites us to explore. From the tiniest particle to the grand cosmological scales, the interplay of yes and no decisions shapes the reality we experience. And as we peer deeper into this framework, uncovering its mysteries, we are reminded that science is not an act of arriving at singular truths. Rather, it is a process of expanding perspectives, finding new ways to reinterpret the map of existence, one binary toggle at a time. Where, then, will this map lead us next? At the heart of our existence lies a paradox. The universe seems improbably perfect for life, yet it's filled with randomness and chaos. Could this fine-tuning be the work of a creator, or is it simply the result of countless cosmic dice rolls? The anthropic principle offers a provocative answer. We exist to ask these questions precisely because this universe is one where we can exist. But does this explanation hold weight, or is it merely a convenient way to embrace the improbable? To understand the anthropic principle more deeply, consider this. The eye of an eagle, capable of spotting prey from great heights, feels like a marvel too perfect to have been left to chance. How could something so intricate evolve from randomness? For many, the sheer complexity of such creation demands the existence of a creator, a guiding hand ensuring perfection amidst randomness. Yet, cosmologists present a counterpoint with the anthropic principle A perspective that offers less divine intervention and more observational inevitability. This philosophical concept states that the conditions of our universe are just right because they had to be for us to be here, asking these questions. It is not necessarily divine, nor is it dismissive of the complexity. It is a reflection of a grand but logical system of existence. Think about it. What if there are countless universes, each with its own physical laws and conditions? Among these, only a few may stumble upon the improbable combination of factors needed for life. Our universe just happens to be one of those few. The multiverse idea, tied closely to the anthropic principle, suggests that for every decision, every possibility, a new universe splits off to accommodate it. And thus, here we are, existing in the one where things align just right. It's not chance that brings us to this reality, but a statistical certainty within the vastness of possibilities. The anthropic principle becomes even more fascinating when we apply it to cosmic concepts like the Big Bang. The Big Bang, often romanticized as the universe's birthday, is viewed through new lenses in this perspective. Imagine this explosive expansion not as a random event, but as the first in a series of yes-no decisions, a gigantic toggle switch flipping, creating something out of nothing. The overwhelming expansion described in inflationary cosmology, where the universe grew at an unfathomable pace, aligns with this reasoning. Was the Big Bang merely the first of an infinite sequence of yes/no toggles shaping our universe from potentiality into reality? The concept also invites us to consider the role of time. Time, typically perceived as a linear arrow, could also be seen as another dimension, one that can be traversed. If time is another spatial dimension, then moving backward toward the Big Bang isn't a retreat to nothingness, but a plunge into quantum indeterminacy. The point where infinite potential collapses into the finite. The first yes/no that reduced infinite possibilities to a singular reality brings forth another thought-provoking question. Is time itself a construct born from this collapse, an imposed structure that helps us perceive and engage with the universe in an orderly manner? Even more fascinating is how the anthropic principle allows interpretations of the same data to coexist. Newtonian physics, for example, provided laws that for centuries predicted planetary motion with precision. When Einstein introduced the concept of gravity as a curvature of space-time, it didn't completely discredit Newton's observations. Instead, it layered a new perspective, illuminating areas Newton's understanding couldn't. Similarly, the anthropic principle doesn't aim to discard standard cosmological theories. It offers an alternate window through which to view them. And here lies the beauty in scientific exploration. Sometimes two interpretations, while seemingly contradictory, can both hold truths. This duality is reminiscent of Schrödinger's cat, existing in multiple states until observed. Our universe, too, may overlap with countless others, their existence unknowable to us simply because we are not in them. The universe where JFK's assassination was thwarted, or the one where humanity perished under the indifference of an alien race. They exist, but not here, not on our timeline. It's not that these events couldn't occur, it's merely that they didn't, in this version of reality. Looking at historical patterns, humans have often been quick to predict the end of times. From ancient prophecies to Y2K hysteria, the inevitability of catastrophe is a recurring theme. Today, one can wonder, what if these prophecies came true, but just not in our timeline? Atlantis might have sunk, Lemuria obliterated, their survivors whispering final "I told you so's" before reaching their dooms, but in alternate universes. On our timeline, for now, we stand on the shoulders of improbabilities stacked upon more improbabilities. Isn't that the essence of the anthropic viewpoint? That this timeline, like a delicate thread chosen out of countless others, feels impossible until you consider all the ones that didn't make it. This concept challenges us, presenting all alternate realities as potential truths. It forces us to rethink our existence, not as a single, isolated miracle, but as one outcome in a web of infinite possibilities, each outcome shaped by an infinite interplay of choices, chances, and circumstances. For every improbable event we witness, there is another timeline where it didn't unfold, where hydrogen wasn't dominant, where life as we know it never emerged. If so, we arrive at a provocative question. If all these other universes exist, why do we perceive only this one? Why are we bound to this reality, shaped by these choices and events? Our critics would argue that the anthropic principle thrives too conveniently on imagination. Show us, they demand, proof of these alternate realities. Prove that this complexity is not a divine orchestration, but the residue of infinite cosmic experimentation. And here, dear observer, is where the idea tiptoes into the territory of faith, not the religious kind, but a willingness to imagine realities beyond the bounds of proof. Could it be that this seemingly convoluted idea isn't too far-fetched, but rather too expansive for our minds to encompass fully? As we unravel this tapestry of quantum mysteries, interwoven timelines, and infinite possibilities, we begin to grasp the humbling truth that the universe, in all its vastness, is both unknowable and deeply reflective of our curiosity. What lies ahead in this exploration, or perhaps more aptly described, what lies within? The answers may be rooted less in conclusions and more in the questions we dare to ask next. Now imagine this You're standing at a crossroads where every choice you've made or could make fractures reality into countless new paths. Now, throw time travel into the mix, concept that shakes the very foundation of our perceived universe and challenges the notion of a singular linear timeline. What if every step through time didn't just change your future but fragmented the fabric of reality itself? Welcome to the paradoxes of time travel. Time travel, a staple of science fiction, has fascinated and perplexed storytellers, scientists, and idealists alike. But what if the fictional framework we've become accustomed to is merely scratching the surface of an unfathomable truth? To understand the paradoxes of time travel, we must first unravel the threads of higher dimensions. Imagine everything you've known a single, straightforward line of time stretching from past to present to future is merely a systematic illusion of simplicity. We perceive time as a progressing arrow, yet quantum theory and multidimensional thinking suggest it may just be a single strand in an expansive web of infinite possibilities. Now, consider the 10th dimension, the ultimate source code of reality, where every yes and no decision, every possible configuration of existence itself, is predetermined yet simultaneously fluid. Each moment we experience is derived from a seemingly infinite number of binary decisions, a series of toggles flipping between this or that. This colossal gridwork of possibilities doesn't just explain the reality we know, but lays bare every potential timeline that could spin into existence. From this vantage point, time past, present, and future might not necessarily flow in one direction. What if the Big Bang wasn't the definitive beginning, but merely the outcome of the first great bifurcation, the initial yes/no toggle within higher dimensions? Inflationary cosmology, with its extraordinary early expansion, aligns eerily with the notion of an immense reality-defining binary switch, the Big Bang, while tangible in its observable effects, might be reinterpreted as the byproduct of linear time unraveling itself from a multidimensional construct. To comprehend what existed before the Big Bang, we must abandon our limited perspective and peer backward into indeterminacy and exquisite fog of potential just waiting for that first choice to erupt. This holographic nature of decisions cascading through dimensions aligns not just with the observations of modern cosmology, but with interpretation itself. Consider this: Newton's equations of gravity, valid and robust in their elegant predictive power, were later reframed when Einstein folded space and time into a singular, flexible fabric. Neither perspective is wrong. Rather, each is a layer over the same truth, seen through different lenses. Much like Einstein's relative time, interpretations of scientific data can exist simultaneously. Which brings us to you, the time traveler. Suppose you tear through the fabric of the present, hurl yourself into the past, and see your younger self at a crossroads, a moment pivotal to your future. Every scenario that could result from this interaction splinters reality into infinite threads. Do you caution your former self, shifting their trajectory, and by extension, your own? Or do you watch silently, knowing that every alternate possibility also exists somewhere within these imperceptible corridors of time? Back to the Future, a beloved fixture of popular culture, scratches the surface of such dilemmas. Marty McFly's meddling in his parents' timeline leads to his gradual disappearance, a poetic embellishment reflective of a singular timeline theory. Yet if we consider time through the 5th dimension, a framework of potentialities, Marty wouldn't fade. Instead, he would simply branch to a new future, one where he never existed in the same sequence. Alternate timelines coexist, layered within the expansive higher dimensions like pages in an infinite book. But time travel paradoxes are seldom this kind. Enter the grandfather paradox, a quandary that questions free will itself. A traveler kills their grandfather before their parent is born, creating an impossibility loop where their own existence flickers between being and non-being. If all potential outcomes exist, could the traveler escape into a timeline where they never fired the fatal shot? Or, alternatively, could we invoke the Novikov self-consistency principle, which claims that paradoxes correct themselves, events reshuffling their course to maintain a stable reality? Terry Gilliam's masterpiece, 12 Monkeys, creatively illustrates this self-correction. When the protagonist witnesses his own death earlier in life, the loop ties seamlessly within the boundaries of that timeline. Similarly, in Stephen King's Dark Tower series, the idea of keystone worlds emerges central universes that anchor structure to the disorderly multiverse around them. But these perspectives invite even more questions. If there are keystone realities, do they diminish the validity or significance of the branching ones? What is anchorless existence but a shifting tide within limitless possibilities? And yet, as paradoxes spiral, choice wrestles for dominance within these landscapes. Every decision you don't make manifests in another timeline. Every path untaken lingers as a shadow in the higher dimensions, waiting, watching. This interplay between inevitability and free will define the paradox at the heart of time travel. To explore it further, we must challenge even our most cherished narratives. But what if I told you that paradox resolution, free will, and branching timelines are just the tip of the iceberg? Because when we zoom past the branching threads, all pasts, presents, and futures simultaneously available, we are left with one burning question. What truly defines reality in a system so sprawling? Imagine a single letter so profound. It took Albert Einstein 2 years to respond, and when he did, it reshaped the future of physics. This is the untold story of how one mathematician's bold leap into the fifth dimension unveiled a new reality, forever altering our understanding of the universe. When Theodore Kaluza proposed his revolutionary idea in 1919, it wasn't just a letter, it was a doorway to possibilities yet to be imagined. His theory suggested that by adding a fifth dimension to Einstein's groundbreaking equations for gravity and Maxwell's laws of electromagnetism, these two fundamental forces of nature could be unified. Einstein, awestruck, ultimately deemed the idea worthy of publication. And thus, the seeds of what we now call the Kaluza-Klein theory were planted a theory that would eventually influence string theory and expand our perspective on the structure of reality. But why stop at 5 dimensions? Modern physics now entertains the concept of 10 or even 11 dimensions to decipher the mysterious forces of the universe. To understand this, we need to first explore how dimensions influence the very building blocks of reality. The fourth dimension, time, weaves space into space-time, while the fifth dimension, theoretically, offers access to alternate realities, different paths that history could take when influenced by slight changes in initial conditions. Beyond these, dimensions 6 through 10 open even more incredible pathways, including explanations for phenomena like dark matter and dark energy. Still, our elevated thoughts of personal control clash with universal truths. While human beings possess an extraordinary capacity for creativity and imagination, we remain bound by the fundamental laws of higher dimensions. Consider the 6th and 7th dimensions, planes that expand beyond our 5-dimensional timeline. Until technology enables us to fold these dimensions or traverse beyond them, there will always remain alternate realities beyond our reach. Ultimately, this realization leads us back to the paradox of control. Each action we take, while significant, operates within a grander symphony of interconnected choices, the vibrations of countless observers, animate and inanimate, shaping the universe's complex patterns. We are both transmitters and receivers, navigating a web of influence far greater than ourselves. The illusion of control, then, is not only a limitation, but also a form of liberation. It reminds us that while we are far from omnipotent, we are participants in something far grander, the unfolding narrative of the cosmos, shaped not just by our individual will, but by the collective desire for continuity, evolution, and existence itself. And it is in these higher dimensions that some of the greatest mysteries of modern science reside. Dark matter, which physicists estimate makes up 23% of the universe, eludes direct detection, but is crucial for explaining why galaxies don't scatter apart like cosmic dust. It's like a silent architect in the shadows, holding the structure of the cosmos together. Meanwhile, dark energy, even more baffling force, comprising roughly 73% of the universe, is accelerating its expansion. Together, these unseen components form 96% of our universe, leaving the matter and energy we can observe as just 4% of the cosmic pie. How is it possible that the majority of our universe is invisible and undetectable? One possible explanation lies in gravitational leakage. String theory suggests that gravity, unlike electromagnetic or nuclear forces, can travel through higher dimensions beyond our familiar three-dimensional space and one of time. If this gravitational pull indeed extends into adjacent dimensions, it could explain why dark matter and dark energy have such profound influences on our universe, even though we cannot directly see them. Researchers have theorized that alternate dimensions might exert gravitational influence, pulling on both the visible universe and the pathways we don't directly experience. Imagine this as a kind of dimensional fabric, where unseen adjacent universes contribute subtle yet significant forces, creating the phenomena we label as dark matter and dark energy. Could it be that the mysterious gravitational effects stem not from particles or substances within our own realm, but from interdimensional forces? If so, the very framework of reality could be far more interconnected than we understand. And then there's the enigma of dark energy. Unlike the pull of dark matter, dark energy acts more like a cosmic push. Physicists hypothesize it could be the result of repulsive forces leaking from higher dimensional brain sheets of energy and matter in theoretical physics that interact in ways we cannot yet measure. What if the universe itself is being drawn outward by the gravitational pull of another, larger brain? This mind-bending possibility would align with the predictions of string theory, where adjacent universes could subtly affect ours. The implications are staggering. Every particle, every force, every interaction we observe may just be the tip of the iceberg. By resolving these questions, science edges closer to unifying the fundamental forces through theories like string theory and M theory, which incorporate these additional dimensions. Along the way, they illuminate the elegance and strangeness of the cosmos, where the tangible and the mysterious coexist in a delicate, awe-inspiring balance. Beyond scientific theories, even Einstein's once dismissed cosmological constant, originally envisioned to maintain a static universe, found redemption in modern cosmology as an explanation for the accelerating expansion of space. This expansion, driven by dark energy, might indeed align with Kaluza's initial vision of how higher dimensions shape our universe. Could it all come full circle, resolving the unanswered questions of a century ago? If we step back and look at this from a broader lens, what we see is a revolutionary framework for understanding reality, not as a simple construct of 4 dimensions, but as a vast, intricate structure stretching across 10 or more dimensions. With each dimension unraveling secrets about the forces that govern existence, physics moves closer to its ultimate goal of a unified theory of everything. Before we end, Consider this: if you were a two-dimensional being, how would you perceive three dimensions? A sphere passing through your flat world would appear as a series of expanding and contracting circles. Similarly, what we perceive as the gravitational effects of dark matter, or the accelerating push of dark energy, could simply be the shadows of higher dimensional forces intersecting with our reality. The challenge for us in the 21st century lies not only in comprehending these dimensions, but in finding ways to probe and test their existence. Whether through advanced particle experiments, gravitational wave detectors, or emerging theories that redefine the boundaries of physics itself, humanity stands at the threshold of understanding its place in an unimaginably vast multiverse. Dark matter, dark energy, higher dimensions. These are not just abstract concepts locked away in equations or academic papers. They are the next great frontier, inviting us to think differently about space, time, and the infinite possibilities that the universe holds. Ask yourself, what might we discover next? How might the mysteries of the unseen lead us to entirely new paradigms of thought? This is where science, imagination, and exploration converge. And this is why the pursuit of understanding dimensions and the mysteries they contain is perhaps the most exciting and profound endeavor of our time. Now, when we think about control, we often imagine ourselves as masters of our actions, our choices, and even our destinies. But is this belief grounded in reality, or is it just an illusion? Today, we'll explore a profound concept that challenges our understanding of control, individuality, and the fundamental mechanics of the universe. What if the control we think we have is merely a byproduct of a much larger, interconnected system, one that unfolds across dimensions far beyond our comprehension? Take, for example, the human body fending off a cold. We've all heard anecdotes of someone saying they were too busy to get sick, seemingly avoiding illness through sheer willpower, only to succumb to the virus the moment they slowed down. Or perhaps you've come across stories of cancer patients visualizing their immune system attacking a tumor, leading to remission without medical intervention. Could these be examples of individuals bending some unseen reality to their will? Could they be tapping into dimensions beyond the four we perceive, navigating alternate quantum paths to achieve these outcomes? Consider the experiment conducted in Washington, D.C. in 1993. A group of approximately 4,000 individuals engaged in transcendental meditation aimed at reducing violent crime. Remarkably, during the demonstration period, violent crime reportedly decreased by over 23%. While skeptics argue that statistical manipulation could explain the outcome, others suggest that this group somehow collectively influenced reality itself. Through focused thought, they may have altered the vibrational energy of their collective environment, effectively bending the fifth-dimensional timeline toward a more peaceful outcome. Physics provides a framework for understanding such phenomena. The concept of entrainment, for example, illustrates how vibrations from one entity can influence another. Discovered by Dutch scientist Christian Huygens in 1665, he observed pendulum clocks synchronizing their swings when placed on the same surface. Could human consciousness work in a similar way? Could the vibrations of our thoughts, desires, and emotions influence others, or even the reality we inhabit? Every day, we participate in what some call a consensual reality. It's the shared perception of the world to which most of us adhere for a set of ground rules, a collective agreement about how things work. This shared reality keeps society functional, but it also creates limitations. If each of us truly had the power to collapse our own version of reality, chaos would seem inevitable. Yet, history and physics hint that individual contributions to consensual reality carry weight. Even the smallest influences, like a drop in a vast ocean, ripple through the collective experience. Take Greg Bear's science fiction novel, Blood Music, which explores the power of collective belief to alter fundamental physical laws. While purely fictional, the idea sparks a fascinating question. Could a high level of agreed upon focus across humanity change the course of reality itself? The answer may lie in understanding dimensions beyond our own. We primarily perceive reality through time and space, our fourth dimensional lens. But the fifth dimension introduces the concept of alternate possibilities or timelines. Each choice, action, and even thought could theoretically lead to a unique timeline. However, our ability to chart a new course is restricted by the collective desires and actions of countless others, not just humans, but all life forms, even microbes, and their simple but vital desire for continuance. Visualize your life as a line graph. Time runs left to right, constant and unwavering, but your emotions, choices, and outcomes cause that line to oscillate above or below a central baseline. Each peak or valley represents a moment of triumph or despair, productivity or idleness. While we may desire to redraw our life's trajectory, to spend more time above the line than below, our path often represents a balance between conflicting forces around us. Psychoactive substances offer a glimpse into the illusion of this balance. They can create a temporary sensation of being above the line, but often, the resulting crash leaves individuals even further below it. The illusion of control, in this case, becomes a cycle seeking highs to escape lows, all while being trapped by the very substances intended to grant freedom. The interplay between control and influence extends beyond individuals. Our collective choices continually shape and steer our shared fifth dimensional path. Global phenomena, like the mass adoption of brand messaging or viral social movements, demonstrate how shifts in collective focus can steer reality itself. Whether through consent or coercion, this dynamic suggests that we hold the power to influence change, but only within the framework of our shared, consensual reality. But what about those who feel control slipping from their grasp? For many, the story of their life is defined by external forces, bad luck, unfair circumstances, or the ill intentions of others. Yet, separating fact from fiction in these narratives is crucial. Personal accountability often plays a larger role than we admit. When we redefine our narrative, acknowledging the choices and actions within our sphere of influence, we can regain a sense of purpose and agency. The 10th dimension is one of the most fascinating and complex concepts that physicists and theorists explore to understand the nature of our reality. To begin imagining the 10th dimension, it's important to first revisit the preceding dimensions and how they interconnect. Each dimension builds upon the last, from the foundational concepts of length, width, and depth in the three spatial dimensions to the intricate and expansive ideas of time, alternate timelines, and possible universes in higher dimensions. First, we need to understand the initial triad dimensions 1 through 3, which constructs the physical space we interact with daily. Starting with a point in the first dimension, extending that point creates a line. When we extrude the line, we form a plane in the second dimension, and finally, by adding depth, we enter the three-dimensional world we live in, with length, width, and height. What sets the stage for more abstract thinking is the fourth dimension, time. Time in this view can be seen as a line tracing the possible states of our universe from its beginning to its end. However, when we consider time alongside the potential for alternative choices and outcomes, we encounter the fifth dimension. Every decision or event in the fifth dimension creates a branching timeline, offering all possible futures stemming from every possible past. The sixth dimension expands on this concept, encompassing not just our universe, but every possible iteration of it, shaped by decisions and subtle variations in initial conditions. The seventh through ninth dimensions take this exploration further by including entirely distinct universes, each with its own set of physical laws. These are the universes birthed from different initial conditions, such as alternate Big Bangs, that are fundamentally incompatible with our own reality. Stacked together, they comprise all known and unknown possible configurations of existence. And then, we arrive at the 10th dimension, which can be thought of as the ultimate container for everything. Imagine gathering every possible universe, timeline, and state of being, all variations governed by distinct physical laws, and every conceivable combination of outcomes into one all-encompassing framework. The 10th dimension represents this infinite set of possibilities. It's where the multiverse resides in totality, unrestricted by limitations of time, space, or even the laws of physics. No system can fully observe or describe the 10th dimension because it exists outside the parameters of any single universe or point of view. To visualize this, consider using an imaginary super camera. At the first level, it captures an image of our three-dimensional space. Move up to the second triad, and the camera now records not just one frame, but every timeline possible for our universe, representing dimensions 4 through 6. Next, imagine taking pictures of completely different universes, each governed by unique laws of physics and containing their potential timelines. These photo albums amass interstacks as vast as you can imagine, representing the third triad. Now, place all these photo albums into one giant moving van. This van encapsulates the 10th dimension, which holds the total sum of all spacetimes within itself. The 10th dimension challenges our perception of reality by hinting at the paradoxes of infinity. For example, Zeno's paradox tells us we can divide a line infinitely, but limits like the Planck length, smallest measurable unit, confine the theoretical infinities on practical terms. It's within such quantum limitations that notions of higher dimensions, such as wormholes or alternate spaces, begin to take shape. The Planck time, similarly, offers a finite interval during which light can travel the smallest measurable distance. Together, these ideas place boundaries on our physical world, yet they don't impede theoretical explorations of the enormous, possibly boundless 10th dimension. The theory of superstrings complements this perspective. Vibrations within this 10th dimensional framework generate all observed matter, forces, and spacetimes. These strings are imagined to vibrate uniquely for every possible configuration of reality. When subsets of these potentialities collapse into the dimensions we perceive, they generate specific physical laws and universes that we inhabit or observe. This process supports the theory that what is real, for us, is only a fragment of a greater far-reaching system. Furthermore, Gödel's incompleteness theorem offers a provocative lens through which to view the 10th dimension. Essentially, no system can fully define or understand itself because it is bound within its parameters. The 10th dimension, therefore, exists perpetually outside of all systems it contains. Every attempt to observe or describe it inherently simplifies its infinite complexity, folding its vast potential into smaller, comprehensible forms within lower dimensions. This progression, from the singular first dimension to the all-encompassing 10th, highlights an elegant philosophical framework for understanding reality. By imagining the 10th dimension, we're invited to think beyond our sensory experiences and scientific instruments, expanding our awareness to consider the universe's grand, interconnected structure. Ultimately, exploring the 10th dimension is as much about physics as it is about stretching human imagination. By contemplating these lofty ideas, we not only reframe our understanding of existence, but also foster new ways to perceive how everything fits together. The 10th dimension, though immeasurable and fundamentally inaccessible, challenges us to accept the existence of infinite possibilities. Now, concept of overlaps and interactions across dimensions can be complex, but it offers profound insights into how we understand the universe at its deepest levels. To help us fully grasp the significance of this idea, we must begin with an important premise. Our universe is an intricate interplay of dimensions that influence each other and weave together to form both our physical and experiential reality. When exploring higher dimensions, such as the 10th, we start to see how different systems such as physical realities and interference patterns interact and shape our understanding of existence. At its core, the concept of dimensions allows us to visualize the many layers of possibility, potential, and reality that underlie what we experience in the 3rd and 4th dimensions. Beyond these, however, lies a far richer tapestry. Every decision, observation, or interaction in our 3-dimensional world can be thought of as a single point within a set of higher dimensional shapes. These shapes, when extended into the 6th dimension, represent the possible pathways and variations of our physical lives, including both the most likely realities and the less probable outlier events. It is within this framework that concepts like Everett's many worlds theory gain a tangible structure, showing how each outcome coexists until collapsed by an observer's choice. Yet, there's more. Traditional views of physical reality often ignore the role of intangible systems, our thoughts, beliefs, and collective consciousness. These constitute the meme systems, which are not physical entities but abstract forces that follow individuals and societies, influencing decisions and shaping culture. Meme systems are dynamic, constantly evolving over time and across geographies. They can flourish, diminish, or even transform radically, which, when viewed in higher dimensions, portray intricate patterns. Just as physical bodies have 6th-dimensional shapes, meme systems have their own peculiar webs and connections as seen from this vantage point. Where things get particularly fascinating is when these meme systems interact with our physical realities. From this interaction, interference patterns arise, new layers of connections and dynamics that weren't present before. Interference patterns can provide a way to interpret choices and pathways, acting as the observer that bridges possibilities in both the physical and meme systems. These patterns, influenced by context and angles of interaction, create a rich field of potential realities. Understanding these overlaps brings us back to our current perspective as physical beings. We live in the 3rd and 4th dimensions, bound by time and space, yet capable of imaginative leaps into the possibilities of higher dimensions. Our awareness may extend beyond this body through memory, creativity, or even collective thought. However, we remain tied to the physical system, our organic form, and the temporal line it follows. The tension between determinism and free will is central to this observation. When we consider free will in light of dimensional overlaps, we see how potential pathways exist simultaneously in the higher dimensions until chosen through observation. This complex web of probabilities becomes clearer when we think about the many selves each of us might express depending on the paths taken. Yet, these selves are embedded within the constraints and possibilities of higher dimensions, always defined by interference patterns and shaped by the interplay of physical and meme systems. By extending this logic into the larger cosmological view, the same principles apply to our universe as a whole. The laws of physics themselves, branching universes, meme propagation, and even phenomena like dark matter can all be contextualized within the interwoven fabric of dimensions. Within the ninth dimension, for example, we encounter rounded shapes that represent infinities of universes. These include universes with different fundamental laws or those that change over time. The ninth dimension portrays the broadest ensemble of possibilities, constrained only by the initial conditions of a given universe. Meanwhile, the 10th dimension brings these ideas to their ultimate conclusion. It represents the full spectrum of all possible outcomes, experiences, and systems that can exist or have existed within the cosmos. By thinking of the 10th dimension as the space where these potentials reside in an indeterminate state, we confront questions that touch on the nature of creation itself. Is this where God emanates from? Is this where all consciousness originates, waiting to manifest below through dimensional layers? Just as Feynman's sum over paths illustrates how particles can reach a specific position through countless routes, so too can we think of ideas, realities, and even broader universal truths taking form as they traverse possibilities. The implications for culture and worldviews are profound, especially when considering dominant memes that endure from the beginning to the end of the universe. These longest surviving memes are likely essential to life as we know it, influencing not only immediate reality, but also its most enduring configurations. Ultimately, overlaps and interactions across dimensions form the connective tissue of reality. They reveal how what seems separate, whether in physical experience, thought, or time, is inherently interwoven. By exploring this vast system, we gain not only a deeper understanding of the universe, but also of ourselves and our role within it. And with that, we've reached the end of our video. We'll see you in the next one. If you have any questions or thoughts, feel free to share them in the comments below.